Hi, Caleb.
Saxon Algebra 1/2, Lesson 54. Two topics. The first one is ratio and proportion. Okay, a ratio is simply a fraction. A ratio can be written in a lot of different ways, but we're going to experiment with it today as a fraction, and that's what we'll mostly use. But it's simply a fraction, so 2/3. That's a ratio. A proportion is two ratios that are equal. And we deal with these a lot when we're talking about fractions and we're adjusting denominators on fractions. So we can say, for example, that 1/2 is equal to 5/10. That's a proportion, two ratios that are equal to each other. So what we're going to do is we're going to learn about solving proportions. Okay, so this is the kind of problem that we're looking at. 20/15 equals 4/x. Now, I know you, Caleb, and I know your brain, and I know you can just look at this and go, oh, well, clearly this number is 3, because this is 4 times 5, and this is 3 times 5, and there's the 4, so that would be 3. Okay, cool, I know you get it, but let's figure out the process. In order to solve this, pretend you don't know x, we have to cross multiply, and I don't know if we've talked about that before, but cross multiplying is the step. I always draw this x when I want to cross multiply because it reminds me that what I'm going to get is 20 times x equal to 15 times 4. We multiply top to bottom and set that equal to bottom to top. That will always work. It doesn't matter if you start with the 20 and multiply the x first, or if you start with the 15 times 4. I could have written this as 15 times 4 equals 20 times x. I like to always start here though, and then multiply down first. So I'm going to lean toward that format, but you can start on the bottom if you want and go up. What matters is that you take the partners, the two factors that go together are the ones opposite each other. Okay, so let's go back to this. I'll write it over here. 20x equals 15 times 4. When you're doing cross multiplication in most problems with John, I recommend don't multiply that through yet. Take this last step of getting all the numbers on one side, right? Because we want to get the x by itself. So we divide by 20, and now I'll rewrite it. X, that cancels, x equals 15 times 4/20. Rather than multiplying this out, it usually works really well to reduce before you multiply. I like to make my numbers smaller before I make them big. Life is easier that way. So I see 15 and 20. I can divide 5 into both of those, and I'll get 3, and I'll get 4. Aha! And then look, I have a 4 and a 4, so those both go to 1. I'm just going to cross them out. So x is equal to 3, which I know you knew all along, but cross multiplying is the tool we use to solve a proportion. So let's do one more, and then we'll switch to our other topic. Example 54.2. 4/5 equals p/7. The letter doesn't matter. This one's a little bit harder. I don't know that you're going to automatically be able to know what goes right there, but our process is exactly the same. To solve the proportion, we cross multiply. I always start here, so I get 4 times 7 equals 5 times p. I want my p by itself, so I'm going to divide both sides by 5. That cancels. Instead of rewriting, I'm just going to look at this. 5 doesn't go into either of those, so I can't reduce that. So I'm going to just skip over here and write p equals 28/5. That's the right answer. No wonder we couldn't just look at this and guess what p was, because it's a really weird fraction. But that's the right answer. So sometimes your answers might be simple like the first one, but more often we're going to get weird and wacky things that you can't automatically see. And so this process of cross multiplication is the tool we use to solve our proportions. Okay, that was part A, ratios and proportions. Part B has a really weird looking title, but when we get into it, you're going to be like, oh, that's not hard. What John's trying to communicate to us is that this is an exponent where we know neither the base nor the power, and this is a root where we know neither the number or the root. So what we're going to do, example 54.3, is we're going to be given numbers to substitute in. There are those evaluation style problems, no big deal. So the instructions say evaluate x to the y if x equals 4 and y equals 3. Okay, so this looks kind of like that. We see where they get the title, but all we have to do is just substitute these numbers in. So 4 is the base, and 3 is the exponent. I know that by looking at the x and the y. 4 to the third power is 4 times 4 times 4. That's 16 times 4, and that's 64. Okay, and so that's this form, and now I bet our second example will look like that. What do you want to bet? Example 54.4. Evaluate, and they have this kind of thing. P, the pth root of q. What? If, that is how you say it, the pth root of q. P equals 3, and q equals 64. Okay, so this looks more like that. So the lesson is we can use different letters, but the formatting will be the same. So now we're going to do the same thing. We're just going to take these and plug them in here. So here's our root symbol. P is 3, so that goes there. 64 goes inside. And this would be a lot harder, maybe, if we hadn't just done this problem. But I know that 4 to the third power equals 64, so the third root of 64 would be 4. Easy, right? You got it. Okay, good luck. That's all there is to it. That's lesson 54. Good luck with the homework. See you for lesson 55.